At 0540 local time, the first wave of Ukrainian beaver drones was racing toward the Shahed assembly complex outside the Donetsk airport. But in order to even make it there, they first had to clear a path through one of the densest air defense networks in the world. And though the Russians had the drones locked up, it was exactly what the Ukrainians wanted. The three beavers lifted out of a ravine northwest of Donetsk and immediately started taking hits from a Russian Tor air defense system. 5 kilometers ahead, 2 missiles punched out of the tree line and arced straight at the lead drone. The operator yanked the beaver down to 1 meter and started weaving between drainage ditches while his latency spiked past 300 milliseconds. The first missile tried to follow, couldn't handle the angle change, and ate dirt 20 meters to his left. The second one passed overhead and detonated close by, close enough that the shockwave knocked his video feed sideways for half a second. Behind him, the other 2 beavers scattered, forcing the Tor to pick targets. All 3 drones were still flying, but now their telemetry showed something worse than missile lock, a slow, steady sweep pattern. This is because the Russian Tor is specifically designed to take out things like beavers. Its radar doesn't need to see you clearly. It just needs to catch the way your propeller blades change the radar signal's frequency when it bounces back. And then it starts walking missiles onto you using steering commands every few hundred milliseconds. The lead Ukrainian operator knew this, which is why he kept the drone in the dirt where the radar energy bounces off the ground and creates false readings about speed and position. But flying the slow meant burning battery faster. Every meter of altitude he gave up was seconds of precious flight time he'd need later. The Tor crew panicked. Instead of waiting to assess and reacquire, they ripple-fired all 6 remaining missiles in under 4 seconds, a full magazine dump that lit up the horizon like a fireworks show. This was exactly what the Ukrainian operators had been hoping for. See, the Tor guides its missiles using something called command link updates. The ground radar continuously tells each missile where to go via radio signals, making hundreds of tiny course corrections per second. But the Tor's guidance transmitter can only talk to 2 missiles simultaneously with full precision. When you launch 8 missiles in rapid succession, the last 6 get degraded commands, recycled targeting data, or sometimes no updates at all for critical seconds. The Ukrainian operators had trained for this. All 3 beavers suddenly climbed to 15 meters, not high enough to make easy targets, but high enough to get out of the ground clutter. That was confusing the Tor's overloaded guidance channels. Then they did something counterintuitive. They flew straight for exactly 2 seconds before dropping back to the deck. Those 2 seconds of predictable flight made the Tor's computer commit to intercept solutions that would be useless once the drones dove again. 2 missiles plowed into empty air. 2 hit the ground trying to follow. The last pair went ballistic, their guidance links completely severed, arcing harmlessly into the distance. The Tor was now empty. 9 minutes to reload minimum. The beavers pressed forward. The Tor crew would already be loading fresh missiles soon, probably arguing about whether they'd scored hits since all 3 drones disappeared into the ground clutter. That confusion meant the Tor couldn't fight back now and would hand off the track to something bigger. That something bigger was already happening. The Buck M3 radar, 5 miles behind Tor, had started painting the corridor with search pulses. Not trying to guide a missile yet, just building a picture of what was moving where. Unlike Tor, which shoots first and asks questions later, Buck takes its time, watching you fly for multiple sweeps, learns your patterns. The Ukrainian drone operators could tell from the way their links degraded in waves instead of spikes. Each wave meant the Buck was refining its track, getting ready to either engage directly or feed targeting data to the S-400 command post at the airport. The lead beaver dropped behind an abandoned gas station as the operator checked his battery, 72%, and falling faster than mission plan because of all the extra maneuvering. The second wave of FPV should already be launching from the forward position to hit the Tor before it could reset. If they succeeded, the beavers would have a window. If they failed, the Buck would get clean tracking data and this corridor would slam shut. Either way, they had to keep moving. Stopping meant certain destruction, but flying straight meant giving the Russian Buck exactly what it wanted. The lead beaver emerged from behind the gas station straight into the Buck's search pattern. The operator's signal indicators started doing something different. Instead of sharp interference spikes like with the Tor, this was a steady pressure that made his video compression work harder. The Buck was taking its time, using its more powerful radar to track the drone even when it ducked behind obstacles. Every few seconds, the radar would complete another rotation, and each time it did, it got a better idea of where the Beaver was heading. The Ukrainian operator pushed his drone under a set of abandoned fuel pipes, not because it would hide him. Nothing could hide from a radar that powerful, but because it would mess with the Buck's math. See, the Buck needs consistent speed ratings to predict where you'll be when its missile arrives. Every time the Beaver flew at an angle to the radar beam or changed speed suddenly, it forced the Buck to recalculate. These weren't huge errors, but they added up, creating timing gaps that might mean the difference between a direct hit and a near miss. Behind the lead drone, the other two Beavers were having their own problems. The second operator's latency had climbed to 160 milliseconds, not from jamming, but from the Buck's search pulses interfering with his control packets. The drone's onboard processor was spending so much time error correcting the video stream that it had less bandwidth for actually flying. The third Beaver had it worse. Its operator could barely maintain visual contact through all the static. Then, the power lines appeared on screen. This was the break they needed. The lead operator pushed his Beaver straight under the lines, using the metal towers and cables to create what radar operators call shadowing, brief moments where the radar can't see through all the metal. For a big aircraft, this wouldn't matter. For a drone the size of a large bird, every bit of interference helped. The Buck's track quality dropped from solid to intermittent. But the Buck wasn't working alone. Somewhere behind it, the S-400 command post at Donetsk airport had started cycling through its sector scans, trying to figure out what the hell was happening based on the fragmented data it was getting. The S-400's radar was designed to track ballistic missiles and stealth fighters at hundreds of kilometers. Asking it to track beavers at treetop level was like using a telescope to find ants. But it didn't need to track them directly. It just needed to coordinate, to make sure somebody had eyes on the target at all times. The lead operator saw his latency stabilize briefly as the Beaver broke through the worst of the Buck's scan zone. But breaking contact wasn't the same as being safe. The Buck would reacquire on the next sweep, and when it did, it would have a better idea of where they were heading. The math was simple. Every kilometer closer to Donetsk meant less reaction time when the missiles started flying again. The FPVs needed to take out that Tor now, or this mission was over before it really began. 5 minutes after the Beaver scattered, 6 Ukrainian FPVs screamed in front of the Northwest at 50 meters altitude. Their operators had been watching the Tor crews scramble to reload, counting the seconds since the last missile launch. The Tor could fire again in about 90 seconds, if nothing interrupted the process. The lead FPV dropped to grass height and accelerated straight at the Tor, while his wingman stayed higher to split the radar's attention. That's because the Tor's computer can only process so many targets moving in different directions before it starts making mistakes. 2 FPVs might not be enough, but 6 FPVs flying completely different profiles, high, low, fast, slow, straight, and weaving turned the Tor's targeting computer into a confused mess of half-complete firing solutions. The Tor turret started spinning, trying to slew onto the nearest threat, but by the time it locked on one FPV, 2 more had appeared from different angles. The crew inside was probably screaming at each other, trying to manually override the automatic target selection. Too late. The first FPV slammed into the Tor's left side, right where the missile magazine feeds into the launcher. The explosion ripped through the thin armor. The second FPV hit the sweet spot under the turret ring where all the electronic cables run. The turret stopped mid-rotation and locked up as smoke poured from every vent. The Tor was done, burning, abandoned by its crew, completely out of the fight. But the celebration lasted exactly 3 seconds, because that's when the Buck battery decided to remind everyone it was still watching. 2 9M317 missiles launched from behind a tree line, their rocket motors lighting up the morning haze. These weren't the nimble short-range interceptors the Tor used. Buck missiles are telephone poles with wings, designed to reach out 40 kilometers and swat fighter jets. Using them on FPVs was like hunting mosquitoes with a sledgehammer. But the Buck crew didn't care about efficiency. They cared about keeping Ukrainian drones away from their radar. The FPV operators saw the launches and did the only thing that made sense. They ran for the deck and scattered. Buck missiles are fast, like Mach 3 fast, but they're optimized for targets that fly predictable paths. The first missile tried to track a Ukrainian Beaver that was bouncing between abandoned buildings, couldn't handle the angular rates, and detonated early when its proximity fuse got confused by ground returns. The second missile almost got lucky. It passed close enough to a Beaver that the blast wave tumbled it, but the operator managed to recover control just before hitting the ground. The 4 FPVs survived. 2 had been knocked around badly enough that the shockwaves from the near misses crashed them into the ground. But 4 was enough for what came next. The Buck had just shown everyone exactly where it was hiding, and unlike the Tor, it couldn't reload quickly. The window to neutralize it was opening, but it wouldn't stay open long. The S-400 was already adjusting its search patterns, trying to fill the gap the blown-up Tor had left. The 4 surviving FPVs regrouped behind a collapsed building while their operators figured out the approach. The Buck M2 still had 4 missiles left. The lead FPV operator made the call. Straight in. The Buck's crew was expecting the evasive FPVs to use terrain masking and pop-up attacks. They weren't expecting a drone to fly directly at them like a missile. Sometimes the dumbest plan works because nobody expects you to be that dumb. All 4 Beavers accelerated to max throttle and spread into a line formation, each drone about 50 meters from the next. The Buck radar, mounted high on its mast to see over terrain, started tracking all 4 simultaneously. But here was the problem. The crew couldn't launch missiles at all of them. They had to pick 1 or 2 and hope those were the ones that mattered, since probability of intercept meant at least 1 Beaver would leak through. The Ukrainian operator watching through the lead drone could actually see the radar antenna starting to focus its beam, probably locking up his drone for the shot. That's when the third wave hit from behind. 3 more Ukrainian Beaver drones had been circling outside the engagement zone, waiting for the Buck to commit. They came in from the Buck's rear quarter, where the radar had a partial blind spot due to the vehicle's own superstructure. The Buck crew had about 5 seconds to decide: engage the FPV screaming at their face, or spin the radar around to deal with the ones coming in from behind. They couldn't hit both. They chose wrong. The radar started to slew toward the rear threat, which meant for about 2 seconds, nobody was tracking the forward-facing Beavers. The lead operator saw his opening and dove straight at the radar array. The Buck crew realized their mistake and tried to traverse back, but radar masts don't move like fighter jet cannons. They rotate slowly, deliberately, because precision matters more than speed. The first FPV hit the radar dead center, punching through the delicate transmitter arrays and into the cooling systems behind them. The explosion wasn't huge. FPVs don't carry much explosive, but it was enough. The radar array folded like a broken umbrella, sparking and burning as high-voltage cables shorted out. A second FPV hit the base of the mast for good measure, ensuring the whole assembly would need replacement, not just repair. The Buck was blind. It could still launch missiles, but without its radar, it would be firing on last known positions and prayers. The crew would probably abandon the vehicle within minutes rather than sit there helpless. The Ukrainians made the decision for them, as 2 more Beavers slammed into the stricken system. But the Ukrainian operators weren't celebrating yet. With the Tor and Buck down, the S-400 system was the only thing left protecting the Shahed warehouse. And S-400s don't go down easy. They're designed to survive the opening hours of World War III. The hardest part is still coming. The S-400 command post at Donetsk airport was having the worst morning of its existence. The system was designed to track ballistic missiles at 400 kilometers, not drones bobbing through industrial districts at highway speed. Without the Tor providing close-range coverage and the Buck handling mid-range attacks, the S-400's operators were trying to do everyone's job with equipment built for something completely different. Inside the 55K6 command vehicle, the crew cycled through every radar mode they had, trying to filter something useful from the noise. The problem was that their massive surveillance radar was picking up everything. Birds, cars on the highway, hot air rising from factory vents, and yes, somewhere in all that garbage, Ukrainian drones. But which returns were real threats and which ones were just morning commute traffic? The computers that normally sorted this out needed input from other sensors that were currently burning. The Ukrainian operators knew the S-400 was struggling because their telemetry smoothed out. No more radar spikes, no more interference patterns, just clean signal, like they were flying in peacetime. That meant the S-400 couldn't get a targeting quality track. It could see something was out there, but not precisely enough to launch a $40 million missile at it. That's when the Ukrainians played their ace, a heavy Ukrainian Ram-2X loitering munition. Basically, a flying bomb with a camera had been circling at 2,000 meters altitude for the past 20 minutes, way outside the engagement zone. Now it dove, not at the S-400 launchers, but at the command post itself. The 55K6 is the brain of the entire battalion. Neutralize it, and the launchers become very expensive lawn ornaments. The S-400 radar finally got a solid track when the munition dropped through 500 meters. But by then, the geometry was impossible. S-400 missiles needed distance to accelerate and maneuver. Trying to engage something directly overhead is like trying to punch someone who's already past your arm length. The crew had maybe 15 seconds to abandon the vehicle. The munition hit the command post roof right above the main processing bay, where all the computers and communications gear lived. The explosion wasn't spectacular, no Hollywood fireball, but the effects were immediate. Every screen went dark, every radio went silent. The entire S-400 battalion lost its coordination in an instant. Individual launchers still had local controls, but without the command post telling them what to shoot at, they might as well have been museum pieces. With the command post now down, the S-400 launcher was now easy prey as 3 Beaver drones slammed into it and its radar. The remaining Beaver operators, who'd been holding position outside Donetsk waiting for this moment, saw their mission timers flash green. The corridor was open. After 15 minutes of carefully orchestrated destruction, every air defense node between them and the Shahed warehouse was either burning, blind, or brain dead. But the hardest part wasn't the fighting. It was what came next. Flying multiple drones through the same corridor as dozens of other Ukrainian units without them shooting each other down requires Rolex-level precision. One mistake, and they'd do Russia's job for them. Before any drone entered the now-cleared corridor, Ukrainian commanders executed something most people never hear about: combat airspace deconfliction. See, the problem with success is that everyone wants to pile through the gap you just created. Without rigid control, you get friendly drones crashing into each other or operators jamming each other's signals trying to use the same frequencies. In this business, this is called blue on blue, and it's taken more drones than some Russian air defense systems. To prevent this, the Ukrainians divided the corridor into layers like a cake. Beavers would fly at 50 to 100 meters. Any FPVs in the area stayed below 20 meters, and loitering munitions held at 200 meters and above. Nobody was allowed to freestyle it. You flew your lane at your time, or you didn't fly at all. At 0600 local time, the first Beaver crossed the commit line into Donetsk airport's perimeter. The operator could see the Shahed warehouse clearly now, a rectangular building with a curved roof, looking exactly like every other military storage facility except for the heat signatures blooming from ventilation ports. Those signatures meant activity inside, either Shaheds being prepped for launch or battery systems charging. Either way, it was about to end. The Beaver dove from 100 meters to 20, accelerating as it dropped. Through the camera, the operator could see Russian soldiers running between buildings, some pointing at the drone, a few raising rifles. Small arms fire wasn't really a threat. Hitting a drone moving at 80 kilometers per hour with an AK is like hitting a baseball with a toothpick. The real danger was the warehouse itself. If the Ukrainians were right about what was inside, the secondary explosions could swat their own drones from the sky. The first Beaver hit the warehouse roof at a shallow angle, punching through the thin metal and detonating inside the main assembly area. The explosion looked small at first, a flash of light through the windows, some smoke. Then the secondary started. Something inside, probably Shahed fuel cells, went up like a fuel-air bomb. The second and third Beavers were already inbound when the shockwave hit them. The second operator managed to maintain control and dove his drone through a hole in the wall, adding its payload to the inferno inside. The third Beaver got tumbled by the blast wave, recovered, but couldn't find a way through the flame and smoke. Its operator made the call to hit an intact section of the building, ensuring complete destruction. Bye for now.